This conference will now be recorded.
So, hey guys, good evening, good morning. Thanks for joining this first session, the demo session. My name is Satish. I've been with Isha Training for last 3 to 4 years. I'm a working professional in IT with 14 plus experience across the SDLC lifecycle, from the product engineering to performance testing, performance engineering. I've been working across uh, various aspect of software development. So today we will look into the topics which we are going to learn as part of this performance engineering batch, and then I'll probably get started with an introduction, and then we'll go over the topics that we are going to cover, and then I'll touch upon one of the topic from a demo perspective, and then we'll have a Q&A at end. But feel free to put your questions in the chat so that I'll answer it at the end. And you can also ask the questions by unmuting during the Q&A session as well. Okay, that is a plan for today. And this session is planned for the weekend, both Saturday and Sunday. We'll get started at the same time that we started today, and it's going to be 2 hours from 7:30 p.m. IST to 9:30 p.m. IST on the both the days in the weekend. Okay, fine. So I presume that most of you who have joined today might be already uh, have some experience in performance testing or testing, or you might be a test lead. Right? So I believe you would be already having a fair knowledge about what is performance testing, or at least what is testing. Correct. And if you're already a performance tester, you might be doing scripting, execution, some level of monitoring, preparing reports, um, and doing some basic analysis. So depending upon your experience, you might be doing all these things in your project, or you might be focusing on only one or two aspects of the performance testing. That's a typical performance tester's uh, role, right? So when you go and position yourself in an interview or to a project, so basically you will be positioning yourself as your experience in scripting or execution, preparing the summary report, doing some high level analysis and monitoring. That is how you'll position yourself. Correct. Um, the intention of this course is to make you uh, um, upskill yourself in the performance, from performance testing to the performance engineering, wherein you would be able to go and tell that in the interview or in wherever you're going to work. In addition to all this testing, you should be able to go and see that you have done hands-on, you've done hands-on in server-side profiling, memory leak analysis, response time analysis, client-side profiling, taking the heap dump and analyzing the heap dump, taking the thread dump and analyzing the same, analyzing the AWR reports, proficient in not only with the load runner or Jmeter, the tools, profiling tools like JProfiler, JConsole, JVisual, VM kind of tools. And you should be able to go and benchmark your JVM, fine tune your JVM as per the requirement, and good in using one of the APM tool when it comes to deep dive diagnostics, right? And monitoring your application infrastructure using both open source and commercial tools. Right? So all these things is what we want you to learn, and then uh, you would make your profile much more attractive and differentiate you with the normal performance testers, right? The typical problem with performance engineering is, uh, so unless you get experience, right, you might not be able to get into those projects. Even if you're in the current organization, uh, to be a performance engineer, they will expect the experience. But to gain experience, you have to work somewhere, right? So it's kind of a cat and mouse, right? So again, from the objective of the courses here is to not only learn everything theoretically, if you could at least practice once with whatever you are learning, if you can do hands-on by yourself, you should be able to gain at least a certain experience where you can definitely go and say that you haven't worked in the project, but out of your passion, out of your interest, you have learned and done hands-on on all these tools, all these techniques by yourself, right? So that you will at least have an edge over other performance testers. That is the whole objective, right? And again, the way we have done is, whatever I do, you should be able to do it by yourself, right? What we need is, basic things are, you would need a machine, your laptop, a latest Java or any version of Java installed, a Tomcat, a server. So we will use a e-library application. If we open that, so the e-library application is running in my Tomcat. Okay, so I will give you the application WAR file, the Tomcat, and I'll also give you a video on how to set it up in your machine. Right, it's very easy. I'll also show you how to do it, but it's not going to take more than 15-30 minutes maximum. Right, so we'll use the e-library application for the performance in engineering. So this is required, and as I said, Tomcat and your Chrome browser. That is a basic setup what you would need. Okay, and then as we move on, you might need to install JProfiler, JConsole, Visual VM, and AppDynamics. You might need to register yourself. All the commercial tools or open source tool, whatever I'm going to use it for every topic, you would be able to use it. You would be able to install it in your machine, because either it's going to be open source, or if it's a commercial, for every tool like JProfiler or AppDynamics, there are trial versions available which you can install it in your machine. So it is nothing like you will not be able to do anything on your own. Everything what I do, you'll be able to do it yourself. Okay, so that is the objective, where you will be listening to the teaching, and then you should be able to go back and then practice it. And by the way, this is the e-library application which will be using it. Okay, it will have one as an admin login, where you'll be able to go and view the existing librarians, and then you'll be able to go and add the librarians. Okay, there is a librarian login as well, where I think my DB is down. I will turn on as I speak. Okay, so both the application setup and the DB setup, I would guide you how to do it on your own machine. Once we get started with the actual sessions, I also have a detailed video on how to do it, but you don't need to worry about these things. These things are very, very simple for you to set it up, right? Probably tomorrow, when if you have time in the daytime, you can go and set it up by yourself. It should not take much time. Okay, I'll ask the team to add that video as well tomorrow. Every day, the video that is getting recorded will be added to in the next day. Since it's a weekend batch, both Saturday and Sunday's video will be added on Monday morning. Okay, Monday morning IST. So that's how it's going to work. Okay, so now if you go and click the view librarian, uh, it should show all the librarians that are part of the application. Okay, I'll come back to the application a little later. Yeah, it has come. So this is one feature. This is add librarian is another feature. You can go and add it. And then there is a As a librarian, you can log in here, and then you'll be able to add a book, view book, written book. There are multiple other functionalities as well. Okay, so we'll be using this e-library application for our performance engineering. Okay, so this is the basic setup you would need: your laptop, a Java, a Tomcat, and the sample Java application which I'm going to give, plus the other tools. Okay, and other tools, as we go on to each of the topics, you can install it before the session, so you no need to complicate anything now. For the initial uh, uh, few days, this should be more than enough. Okay.
So we will using the Java application or .NET as well.
The complete course is I'll go over the topics and then I'll come back to this question, but it is going to be a Java application.
So same concept will work for the means .NET as well, or there is a little bit different as also.
uh, the 50% of the concepts are going to be same. Remaining is going to be different for each of the programming language, be it is a Node.js or .NET or Python. So depending upon the programming language, depending upon the development platform, what they're going to use it, it is going to vary. But fundamentally, when you say, obviously it is a very vast, right? You cannot go and learn everything. But Java is something very common in every enterprise application. And from an interview perspective, from the applicability of Java in any enterprise application, we have picked Java in the performance engineering. Okay? So once you're able to gain knowledge, once you're able to learn Java performance engineering, you should be able to adapt to the others as well. Right? 50% of what you learn, you'll be able to apply to any other languages or any other platforms. Remaining thing, you should be able to scale up based on the knowledge, based on the experience that you gain from the Java performance engineering.
Okay, yeah, thanks.
Yeah, fine. So yeah, very quickly on um, the what you learn from the what you need out of the performance engineering, right? So I'll go over this SDLC cycle so that you'll be able to a little bit understand. Okay. So normally for performance testing, as I said, you'll be doing your scripting, execution, analysis. Pretty much it will be around this testing stage, right? Whereas when it comes to performance engineering, you will be much more relevant throughout your life cycle. That is one more advantage or one more critical thing in today's agile, in today's DevOps world, right? Where there are going to be small pod team, you're not going to have a large team. So you should be relevant in your project for longer duration, right? Because a lot of scripting is getting automated using your AI, Gen AI. Your reporting is getting automated using AI and Gen AI, right? So, which means you should expand your skill set so you're going to stay relevant throughout your life cycle from the requirement till your production, right? So, from engineering perspective, from when you say a requirement stage, right? It's not about the user stories that a developer will get it and then is going to understand the user story for a development. It's more than that. It's more about the architecture. It's more about the non-functional requirement what business is uh, 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 going to come up with, and then based on that, the architects and development team is going to come up with the architecture. So we as a performance engineer, maybe not at the beginning, right? You as a beginner, you may not be able to play any role in the requirement stage. It maybe you will be doing the non-functional requirement gathering or analysis, but not the architecture review or the design review. But once you gain experience in the application, in the performance engineering, then you would be able to go and analyze the non-functional requirements and analyze the architecture, and then see whether the architecture design which has been given by your development team, will it meet your non-functional requirement, right? Your business will say that my login has to come up with 3 seconds, but when you look into the architecture, you no need to wait till the application is developed, and then you go and test it and then say that your login is 5 seconds, 6 seconds, right? you still need to test it. But when you look at the architecture, if you see that there are multiple hops, there are multiple components involved in login, and if you feel that the 3 second is not going to be possible at all with this architecture, then it is very good, very important to discuss at that stage itself, so that either your product owners will compromise the 3 seconds response time, or your architect will be able to go and revise the design, so that somewhere we can come into a um, some trade-off, right? Rather than testing it and then people getting surprised with the numbers, and then we go and change the architecture, it's going to be a delay of making your product available in the market. Right? So, as a performance engineer, as you gain experience, you will play more role in the design and requirement as well. During development stage, right? Development of your services, your web pages, your all the functionalities. When the application is getting developed, when your services are getting developed, you as a performance engineer should be able to go and take those services, take those functionalities, and then go and conduct your either your CPU profiling, your response time analysis, your leak analysis, and then make sure that you arrest the problems, if at all there, at the single user level itself by doing this profiling, right? So that's very important, because every response time, every time that you reduce, every second you reduce, every memory leak you avoid at the beginning, it is going to help you in a better quality of code that is getting deployed in your testing environment when you do a load testing. So lesser defects will be there in the performance during performance testing, which means it will be a smooth deployment to the production, right? That is one aspect. Second is your capacity. Our ultimate goal, performance engineering ultimate goal, is to reduce the cost. When you say reduce the cost on the infrastructure, right? If your response time is more, if your application is having a memory problem, then it would need more CPU, it would need more thread, it would need more capacity of your JVM. Unnecessarily, you'll be spending too much of cost to your infrastructure. Okay, see, with cloud, you will have a liberty of getting more missions. Okay, but it is not at the cost of paying extra money to your cloud provider, right? So, as a performance engineer, your role would be to work along with the developers and then profile and provide recommendation during the development stage itself, right? And you'll also be involved in arriving at the monitoring strategy, JVM benchmarking. All these things are going to happen during the development stage. Okay, and during testing, it's not only just doing the testing execution, it is more about monitoring it, doing the diagnostics if the response time is bad, if the memory is bad, taking the heap dump, analyzing the heap dump, if CPU is high, if the thread utilization is high, taking a thread dump, analyzing it. All these things are going to be part of your performance engineering responsibility. Okay, so more skill you have, more work you will have during the in the project, which is very, very important, right? You should be more relevant, you should be able to contribute more in the any project, so that you will not have any fear of losing out your position to other people, or losing out your position to the AI or Gen AI, right? And then once the application is in production, again you have to monitor the application in production, look into how the application is performing, how the capacity of your applications are there in production, and then getting those insights back to your testing strategy is very important. That's why monitoring the production is very important. So real user monitoring or synthetic monitoring, all this is something you need to will be doing it in the production. Okay, this is what the across life cycle is required, and in the batch, in the this training batch, we will try to cover most of these things as part of our topics. Okay, so I'll move on to the topic. Last 15-20 minutes, I was trying to give you the introduction, and then what is something you can expect from the course. Okay, so now coming to the topic, I'll probably spend some 5-10 minutes to go over this one by one. Okay, as I said, this is being a Java performance engineering. 50% of the topics are going to be towards that. right? We will have two introduction session on Java and JVM. It's mainly to break our myth around certain areas, right? Normally, when we go and report response time issues to developers, right, we always will have a tough time justifying it or proving them there is a problem. They're always going to find mistakes in our script or in our test data or in our environment. They will say that application is all good. It could be a problem with your script or test data, right? Many of us would have observed this kind of a behavior or this kind of a feedback. Now, you as a performance engineer are going to go and tell the developer that there is a response time problem and there is a problem with your class file or with your particular method. Or you're going to go and say that there is a memory problem and this class file and this object is having a leak. And you're going to go and say that there's thread contention, there's a thread lock at this class file. So you're going to go and talk and tell developers more about the methods or class or objects, the language which they are well aware of, well experienced, right? So we don't want to go and talk to them with a less confidence, because if when you go and say response time issue itself, they will not accept. Now, if you're going to go and tell at the class level or method level, they can easily convince you that there is no issue. Okay, so you should feel confident, you should not feel ignorant, you should not feel that you don't know all these things, right? To break that barrier, we will spend a day or two on learning some of the Java basics. We'll do some hands-on Java program in a way that these things are not going to be a black box. You should not think that what is a class, what are the methods, what are the object, how one class file can call another class file through a method, our SQL DB is getting connected, or our third-party API is called from your Java program, right? How a jar file is created, how a war file is created. So more from the objective of learning these things from an engineering perspective, not from a development perspective. We're not going to go and develop code. We're not going to go and develop application. But since we are going to be working on performance engineering, these things should not be a black box. You should have a very good view on, okay, this is what developer is going to do in this work. This is how he is going to create programs. This is how he is going to create classes methods. This is how he is going to compile. This is how he is going to deploy it. That kind of a view you should have it, so that you will not have any problem in going and explaining the performance issues. Okay, so first initial 1 or 2 days we'll go and learn Java basics, JVM basics. We'll go and do some programs in Eclipse, compile it, execute it, right? All these things we'll do it in the uh, initial sessions, and then we'll get into a performance engineering, where, as I said, during the development phase, we will assume that you are working in a project where you, as a performance engineer, you're going to profile the application as and when it's being developed. So e-library application, we'll take login, we'll take view library and other transactions one by one, and then go and start with the either response time analysis for the login functionality, memory leak analysis for the view library, and right. So the live application, we will take it and then do the performance engineering more from the your shift left or early performance, right? So we'll start with the response time analysis. We'll use tool like we'll use tool like JProfiler, access logs, Chrome developer tools, right? Both for your response time analysis and then also for your memory analysis. Okay. Before going to the memory analysis, we will learn about your JVM memory architecture, heap, stack, and other components of your memory. We'll try to understand practically with few programs on the stack overflow error, and then we'll go into the memory leak analysis and then identify the memory patterns using JProfiler for your login or view library and transactions in the e-library application. Okay, and then from a memory perspective, we'll probably have 4 or 5 long sessions on leak analysis, heap dump analysis, garbage collection, collectors, GC logs, GC tuning flags. All these things we will be learning as we move on. Okay, so we'll start with the response time analysis, CPU profiling, client side profiling, and then Java heap and stack, memory leak analysis, heap dump, and then GC. Okay, and then we'll move into the threads, Java threads, thread contentions, thread dump analysis. Okay, so there are 3 aspects which will decide your capacity. If you look into the course content, initially we will touch upon these 3. One is your response time, memory, and thread. The reason is for a JVM or for any server where your application is going to run, your overall capacity is going to be determined by CPU, memory. Correct? If you take any laptop, any server, your specification is going to be, say, I need 16 gig RAM and then 8-core CPU or a 4-core CPU, right? And then out of this CPU, out of this memory, something is going to get allocated to your application. Correct. So always there is going to be a limit. Even if you take a very big server, there is always going to be a limit, right? So your application is going to consume CPU, application is going to consume memory. So which means it's very important to analyze and optimize the CPU consumption and memory consumption. When I say memory consumption in the Java world, it is going to be heap. So uh, analyzing the heap and then arresting the leak. We'll learn what is leak and all later. We have to make sure that your memory is optimally used. Second is CPU. When it comes to CPU is related to your thread, and thread is related to your response time. Because see, when you access your login, you type in login user ID, type in password, enter submit, and this submit is going to be handled by your thread. Correct? And your authentication can get completed in 1 second, can be done by 3 seconds, or you can go to 5 seconds, 8 seconds, right? So more the response time, more the thread is going to be active, and more it's going to use a CPU. So higher the response time, more the CPU utilization. When you try to reduce your response time, your CPU will also be used optimally. So our objective of engineering this to reduce the response time if at all possible, and so that your thread utilization is going to be reduced, your CPU is going to be reduced. Same way, you will optimize and make sure that there is no memory leak so that memory is used optimally. This will determine your capacity of your JVM. Well optimized JVM can handle more load. So in the JVM benchmarking, after learning all this heap analysis, your threads, response time analysis, we will have a JVM benchmarking session where I will learn about for benchmarking your JVM in terms of how much CPU, how much memory, how much heap, your thread utilization, your thread count, all these things. How are we going to configure? We'll discuss about the JVM benchmarking. Okay, and then as a performance engineer, I told you have to be part of your monitoring strategy. See, we spend a lot of time in scripting. We spend a lot of time in execution. Why we are doing it? To identify problem. Not only looking into your load runner Jmeter report is sufficient, right? It is important, very important, because that is where you see all the response times, errors, and all. But it's equally important to make sure that your servers are going to be proper, right? Every component in your architecture that you're responsible are you should be able to monitor those servers and then make sure that they are in an optimal state. None of your components should be having overutilized CPU or memory or thread or heap, right? So very equally important. When you look into the load runner Jmeter report, it is also very important to look into your server side vitals. So you should create a monitoring strategy based on your architecture. What tools are available? What components are there? How are you going to monitor? All these things should be part of your monitoring strategy. Okay, so we will go on after monitoring strategy. We will go and look into three things from a monitoring. One is your using open source, a popular stack called Telegraph, Inflex, and Grafana to monitor your infrastructure. So earlier we used to use Perfmon, we used to use the vmstat top commands for Linux, right? Now, when doing it all these things manually is very uh, time consuming job, right? So we today's world, it is getting automated using these components like Telegraph, Inflex, and Grafana. So we learn how to install these tools, how to configure it, and how to create dashboards. We'll learn the open source monitoring. And similarly, we'll also go and look into the AppDynamics. Okay, so this e-library application, whatever it is running in my machine, right? So we'll also try to go and um, connect with the AppDynamics, which is running in the cloud, with our own e-library application, and then we'll see how to configure it, how to connect the Appdynamics agent with your Java application, and then how to monitor it. We look into your DC analysis, heap utilization, your memory analysis, all the transaction response time, how to diagnose the problem, how to create alerts, events, taking a heap dump from Appdynamics. All these things we will look into it in the Appdynamics. Okay, so learning an APM tool is very important as a performance engineer. If you're already using it, it's well and good. If not, you should be able to at least have a hands-on in one of the APM tools. It can be AppDynamics, it can be Dynatrace. There are multiple APM tools, so it's not required to go and learn everything. At least one tool, if you have hands-on, then the same thing is what you're going to do it in any other tool. Any APM tool, you should be able to go and look into the response time of your business transactions. You should be able to go and look into heap utilization, memory utilization, your GC, and then you should be able to diagnose your response time problem, set some alerts. All these things are all common for every APM tool. Okay, Datadog, Neuralink, Dynatrace. So you at least you try to get hands-on in one of your um, APM tool. So in our training course, we will go and learn the AppDynamics. Okay, so already my application is connected to the AppDynamics. Okay, and will try to configure and then learn how to configure and how to look into all these things during the session. Okay, and then moving on, we'll also try to understand the Oracle as a database, the architecture of the Oracle, and from a performance perspective, a couple of important parameters like your buffer cache, your AWR report, how to analyze the AWR report, what all things has to be look into it, parsing efficiency, hard parsing, hot parsing. So all these things we'll learn from a database monitoring. Okay, so from there we'll look into the non-functional requirements, engineering strategy, how to create engineering strategy for your agile projects, because all these things you cannot do it for every release, not possible, right? For a new application you will be doing it, all these things. For a major release you will be doing all these things, but in agile, where a sprint is going to be for 2 weeks, a release is going to be for 1 month or 2 months, right? You have to do it, pick and choose these things depending upon your release features, right? So we'll go and try to understand how we will write the engineering strategy for a agile as well, right? And so all these things are all from engineering topics. Since there is DevOps and cloud, or Kubernetes, containers, pods are all something. Wherever you go, you will hear these terms and terminology, right? So to make yourself at least aware of all these areas, so we'll have a future ready, under the future ready category, we'll have introduction to all these things, introduction to DevOps, synthetic monitoring. We'll learn how to create synthetic monitoring scripts, configure it, execute it, analyze your production uh, application using Dynatrace. Right? And similarly, we'll also go and look into the cloud resiliency, auto scaling. Even in cloud, there is a myth why we need to do performance testing, right? Because your cloud is going to provide you the service. So, what is the myth around it? Why it is still very important? What are the additional scenarios you will be executing in cloud? All these things we'll be learning as part of the future ready. Okay, so that is what we'll be learning over the 2024 sessions in the next 1.5 months. Okay. Um, Again, as I said, the course is going to be between 7:30 to 9:30 p.m. IST, Saturday and Sunday, every weekend. So I'll pass it here. If you guys have any questions, feel free to put it in the chat, or you can probably unmute and ask questions. Yeah. Anybody have any questions on the
Hi,
course content? Yeah, please go ahead.
hi. This is Pradeep. I'm working as a QA manager. I have been working with the performance testing, more than 14 years now. I'm becoming a QA manager role. So only one thing I'm, trying to understand, the impact of AI on the performance testing area. Is there any advantages you see implementing the AI with any, AI integrated automation to performance tools, and which can help reduce the scripting efforts? I just want to understand that.
Um, See, AI or the generative AI
Yep.
will play a part definitely in
Mm-hmm.
scripting,
Okay.
analyzing in both areas. Okay.
Okay.
Scripting, when it comes to scripting, right, for web services, for the API based services, automating
Correct.
it using AI is will be a little bit straightforward because
Mm-hmm.
the definitions are going to be there in your digital file, or it's going to be there in your SOAP collections or in Postman collections, or even in from a developer artifacts. If you see, you will have it in the your Swagger kind of a document, right? So where everything will be well defined. You will have a what are those get calls, post calls, what is the endpoint, what is the request body, request header, all these things are going to be there, right? Normally
Yeah.
when we create Jmeter script, right, we look into
Yeah.
that and then we'll go and create those scripts, and which means for even for GenAI it's going to be very easy. If you're going to pass on this some of the sample Jmeter script and then pass on the this Swagger JSON, Swagger YAML, it
Mm-hmm.
can create the scripts automatically, right? So scripting is
Okay.
definitely something GenAI can do it for web
Mm-hmm.
services. For UI it is little bit challenge because all this correlation and for it
Yeah.
has to it recording is there, right? Which Jene cannot go
Correct.
and do a recording and all. So UI it
Correct.
is going to be a little bit challenging, but it can still probably try to automate from if you can provide a R file, right? If you
Mm-hmm.
give to R file, it can try to probably create the script or also apply some correlation. So to certain level, it is still going to be possible, right?
Okay.
Yeah, from a scripting perspective, there's definitely a scope for your automation using AI or Gen AI. But result analysis, definitely
It's really
analysis, observation, recommendation, definitely
recommendation.
can do a very good job.
Correct. Yes. And do you see any potential tool, commercial tool, like NeoLoad or something, which is really finely integrated with the AI tools and which can help us coming future?
I uh, See, I'm surprised why they haven't come up with till today.
Correct.
Yeah,
Yeah.
but the reason is it's pretty much application specific and context specific, right? So it's going to
Correct.
be difficult for them to generalize it. But if you see
Correct.
Datadog or AppDynamics, they have brought in all this Gen AI already because
Yeah.
irrespective of application, it is all going to be
Then
your server logs. It's going to be your
correct.
server
Monitoring.
configuration,
Yeah.
monitoring. It's going to be a little bit generic, but when it comes to
Correct.
scripting, it's always going to be contextual to your application. So that's why I think even Micro Focus or OpenText haven't done a lot in this area so far from a
Yes.
scripting perspective. So they're
Correct.
letting the end users or the teams, the project teams to do that by themselves, leveraging the load runner or JMeter components.
Components. Yes. Perfect. Yeah. This is what my understanding as well. But
Sure, sure,
I'm just trying to see something coming up very soon.
sure, 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 sure. Sure, no problem,
Thank
no
you.
problem.
Thank you.
Yeah. If you guys have any questions, feel free to put it in the chat or in the you can unmute and ask. So what I will one more thing what I want to say is the all these softwares, right? You can download it from the internet as well, okay? And also you will get an access to the Google Drive. Once you register, you will get an access to the Google Drive where all these JProfiler, Tomcat, everything will be part of the drive. Okay, let me go to the drive quickly. So people who have already registered, right? Please share your email ID. I'll go and give an access to this Satish PE August folder. So where you will get all these folders and files where you can download and set it up. For example, for the your e-library application, a Tomcat folder will be available here. This is the last one is a Tomcat folder, and then you would be having for every topic, right? For a response time analysis, you will have a folder inside which you will have a corresponding WAR file which you can download, and also you will have the reports which we will create during the session will be available here. Right, and if you go back to the memory analysis, you will have one for memory leak, you will have for threads, you will have for GC. So this drive will be available for you to download the materials or download the war files, the script, all these things, whatever we are going to use it, you will be able to download it from here. Okay, most of the tools you will be able to get it from the internet, like JProfiler, memory analyzer, your JVisual VM. Most of the things you can download it from here or as well as from the internet as well. Okay. Also, I wanted to probably show you something else as well. Let me open my Eclipse while you ask questions. I'll try to open the Eclipse. What the way we are going to do is I have the code as well for the e-library application. Since I have a code with me, I would be able to go and also if we find problems with the say response time or with the memory, from a role and responsibility perspective, we should be able to go and tell the project team or the customer this is where the problem is. The problem is there with this particular class or particular method, particular object. That's what we are going to show. That is what we are going to share. We don't need to go to the log, or we don't need to go to the code and then pinpoint the exact code or provide the recommendation. That is not something our responsibility at all. Okay, in many places we'll not even get access to the code, right? But so changing the code or fixing the code is not our job, right? Only pinpointing the problems and providing them the root cause of which class, which method, which object is having a problem is our that is where our scope is going to end. Okay, but in our session, right, we'll also try to go and since we have a code of this e-library application, we'll try to correlate with what is there in the code, what could have caused this problem, so that you can go and look into that class file, look into that method, so that it won't be a black box for you, right? So we will go and fix the problem in the code, and then we'll again deploy it, and then again we'll run it. So that's how we will try to learn, at least from our session perspective. But in the project, you no need to do that. So you don't need to worry about whether I should know Java or whether I should know how to use Eclipse. Not required. I will show you just for your understanding. For your when in AppDynamics or in JProfiler, it will say that your response time is high because this class file, this method is calling that class file, and that is where the method is taking more response time. So instead of that being a black box, since we have a code for the e-library, I'll go and show that exactly what JProfiler shows and what is there in the your Eclipse project as well. Okay, if you're interested, you can also set up this Java project in your mission, but it's not mandatory. So somebody, if you're don't want to do it, absolutely not required at all. Only if you're If you want to do it, if you are interested, you can. I'll also provide you the Java project which you can set it up in your machine itself. In AppDynamics, will you teach in mapping of queue, architectural mapping? I didn't understand that. Can you explain that question? See, when you say architectural mapping, right? If I go to the AppDynamics,
Uh, like
yeah, please go ahead.
dashboard creations, like those queues and all needs to be configured, right? Will you teach in that level or how it will be? Like for the
Uh,
architectural mapping, like if there is web submission, if there is message queues, those kind of submissions and all, like we need to map those things, right? In while creating the dashboard.
See, while creating a dashboard, why do you want to go and configure the queue by yourself? See, the if you have in your architecture, if you have a application server, you might be having a TIPCO, or you might be having a MQ, RabbitMQ, or a Kafka, or third-party services. Once again, I'll mute. There's a lot of background noise. Yeah, thanks. So there will be a lot of components, right? In each component, AppDynamics has to be installed and configured. Correct. So installing the agent and configuring it is not a job of performance testers or performance engineer. Okay, it is installing AppDynamics, configuring AppDynamics, installing agent in each of these server components. It's not a role of performance tester or engineer. It has to be done by the AppDynamics admin or Dynatrace admins. Okay, so you as an end user, you're going to go to AppDynamics and look into the already configured application which is getting going to listed here. For example, here I see my Java layer, I see my DB layer, right? And then I go into the business transaction, I will go into the servers, I'll go into look into heap utilizations, CPU utilization, remote services, DB calls, and then I can also go and troubleshoot the slow response times. All these things I'll do it. But configuring the queues and all, we will not do it. It has to be done by the respective architects of that component, or it has to be done by the AppDynamics admin.
Okay, thank you.
Yeah. There's one more question. What is Kubernetes? It is based on cloud architecture. Yeah, it is for your containers, your Docker images, Docker containers, right? See, the war file which is running in my machine, right? The Tomcat. Just one second. Yeah, sorry guys. So see, the war file is running in my Tomcat, right? In my laptop, correct? Um, in cloud, you can do the same thing. You can take this war file and you can install Tomcat in the cloud machine, and you can run it. Okay, so to improve the effectiveness of the deployment, to uh, um, to avoid some of these installation problems. See, earlier, right, what will happen is development teams will say that everything is working in my machine. Testing team will say that working in my machine, same code, but because of the configuration and because of the dependencies, because of the other software dependencies, it might not work well in from one environment to another environment. So to avoid that, to bring that consistency, to improve the deployment, the Docker images came into the picture, right? And so they will create an image of the entire application and they will distribute it so that they can easily go and deploy it in the one from one mission to another mission. Okay, so which means orchestrating these containers, orchestrating these Docker images, that is where again that is one of the challenge, right? In multiple missions we have to run these containers, deploy these images. So Kubernetes is more of a orchestration framework for these Docker Docker containers and nodes. So it has nothing to do with the application itself. So you have an application developed by developers. It can be installed in a VM in a Tomcat directly, or the entire application can be converted into an images with all the dependencies, and it will get in. It will be running in a container in a laptop. So it is one layer above it, right? You have a WAR file which can be running in a VM, or the entire WAR file and other dependencies can be bundled, and we call it as an image, and it will be running in a container in a laptop. And there will be multiple containers in a laptop, or in multiple machines the containers are going to be there. To orchestrate it, there is something called Kubernetes. Yeah, it is, as you said, it is more relevant from a cloud perspective. So we'll try to understand how this architecture is going to be there, and these terminologies, so that when you go into a project or when you go into interview, you will be definitely questioned upon these terminologies, right? We are not going to be doing lot in those areas, but you should know what is what, so that you will be able to answer those questions, and it won't be new when you go into any projects. Okay, there is one more question on single user. Is it required or not? Right? Single user performance engineering. See, when we do early performance, when we do this response time analysis, this memory leak analysis, there's always going to be single user. Okay, we don't want to put load and find problems, right? We'll, as a developer completes the development, we'll take that code, deploy it, and then when I say deploy it, somebody is going to deploy it. If you are not, somebody will deploy into our profiling environment, and with single user itself, we will measure the response time and then see how it is. Is there any problem with the your server side or a client side? Is any method is taking more time? And then we'll provide that recommendation to the developer. Okay, for even for a single user, if the response time is high, definitely it is not going to be good for your load. Same way for memory analysis, for a single user, we will multiple times we will iterate your login functionality or view librarian or any transaction and see the memory pattern. For a single user, how you see memory pattern. After the transaction is completed, when we run GC, memory is coming down or not. So all these things has to be done only at the single user. It's not required to do at the concurrent user at all. Okay, so shift left performance engineering or early performance engineering is always going to be, from a profiling perspective, it's going to be single user only.
Shiva,
Okay, go ahead. Yeah, there's one more question which I want to answer. Yeah, go ahead.
yeah, currently we are using these many tools for a web application. For a mobile performance testing, which are the tools we are using for that? Can you please explain?
Sure. See, when it comes to mobile, right, there can be two things. One could be your web application, which can be accessed in mobile, your m.dot site, right? So Amazon.com, I can use it in my laptop. I can also open in my mobile, open the Chrome browser. I can go and type in Amazon.com, right? For this, the approach, tools, everything is going to be same, because it's a same application. Only the your it's various channel, right, from mobile or from the your laptop or from your Mac. So for that, nothing is going to change. But when it comes to your mobile app, right, native app, which is something you're installing it from Play Store or App Store. For that, the backend, when you look into the backend, right, from your mobile app, it's going to call your microservices or it's going to call your APIs. Great. So from a backend perspective, the tools for testing and engineering is going to be same. End of the day, the APIs are going to call from mobile or from your browser. It's still going to sit in your server. Still, it's going to consume CPU, memory, heap, everything, right? So your API level performance testing, API level performance engineering, heapdom, threaddom, leak analysis, GC analysis, everything is going to be same, even for mobile app from a backend perspective. When it comes to front end is where there will be a little bit difference, because your app is going to be deployed in your mobile, right? That itself is a small application, a small WAR file that will be running in your mobile. So which means you have to do a little bit more analysis on your client side. So in your web application also, you have to do a client side analysis, right? So using developer tool, we'll be looking into the time to first paint. We will learn all these things here as well. Time to first paint, your time to first byte, your rendering time, all these things are important from a browser. When it comes to mobile app, since it's an application by itself, when you download your Amazon app or when you download your net banking app, your gaming app, the app itself is going to consume CPU. It's going to consume memory, right? Every app is going to consume memory and CPU and battery as well, correct? So when it comes to Android, you'll use tools like Charles Proxy, you'll use tools like Android SDK, Android Studio to analyze the CPU, memory, battery, and the way your mobile app is communicating with your backend. So that is an additional tool you may have to learn from a mobile performance testing. For Android, Charles Proxy, Android SDK tools, Android Studio, and for iOS, again it's going to be Charles Proxy plus Android iOS will have something called Xcode. Xcode is a SDK for your iOS, right? So Xcode instruments, Xcode instruments, and then Charles Proxy for iOS, Android SDK, Android Studio, Charles Proxy for your Android. That is an additional tool you may have to learn and then use it for the mobile performance testing projects.
Yeah, thank you.
Sure. Can I use the JProfiler during the load testing? See, there are tools very specifically designed for certain purpose. Like the tool like JProfiler or any profiling tool, if you take it, right, that is meant only for your single user profiling, right? You manually navigate your web application or your API in Postman and then profile it in JProfiler. We will learn that anyway in detail. That's only for single user. When you're going to do a load testing or a endurance testing, there are going to be 500,000, 2,000 users are going to be hitting the servers. That time you should not use JProfiler. You cannot use JProfiler because you cannot do any live recording or live profiling during that time. Not possible at all. Right? And tools like JProfiler should not even be connected during the load testing because JProfiler is going to put additional load on your server. Okay, so JProfiler is meant only for your early performance engineering, single user profiling. While doing a load testing, to understand if there are memory issues, see if for monitoring it, you will use AppDynamics, Dynatrace, or JConsole kind of a tool to monitor it. If there's a problem, then you cannot do profiling that time. Rather, you have to take a dump. You have to take a snapshot at that time. If it is for a memory, you will take a heap dump. If it is a CPU problem or a thread utilization problem, you will take a thread dump. Okay, so it's JProfiler during early performance engineering for your CPU or memory profiling. During load testing, it will be a heap dump or thread dump. That's a difference. Any more questions, guys, before we close it out today, and then we'll continue tomorrow? Any other questions? People who have registered, please provide your email ID. I can provide you a drive access. And anybody have any questions on the registrations? Feel free to reach out to the admins of the WhatsApp group or Kumar sir. He can help you out with the registration process. If you guys have any questions on the course content, or if you think that you need to discuss on whether it is relevant or not for you, tomorrow being a Sunday, we can connect whenever we are available mutually, and I can answer your questions. Yeah, where to register? Yeah, you can reach out to the WhatsApp admins. I'll message after this session is over. I will message in the group my number and also the admin number. You can reach out to them for the registration. Okay, thanks guys. We will meet tomorrow same time and we'll continue. Yep, thank you.
Thank you.